I'm going to solve the question number 4 from the exam, which is talking about a car traveling at a constant speed of 50 meter per second. The car is just moving on this path, and the motorcycle is just standing at this position, as we can assume it as x equal 0 here. After the car passes from this position about 1 second, the motorcycle is just started his movement with 4 meter per second square acceleration. Now for the motorcycle to catch the car, he must have the same position of the car after some period of time. Now for the car, for the displacement of the car, we can write this equation, which is x of the car equal the velocity of it times the period of time that we have to found for the car. And for the motorcycle, delta x equal x minus x initial, which is x initial here, it's the same here. I assume it as x equals 0 here. And x here is just the same x here for the car and for the motorcycle. From the motion equations, delta x equal v initial t plus half of acceleration times t square. But for the motorcycle, it just was standing with no moving, which is mean v initial equals 0. And we can simplify the x of the motorcycle as this equation, which is x of motor equal half of a times t square. Now, to catch the car, we have to put x of the motor equal x of the car. And by substituting the equations that we found before, but here we must write that for the x of the car, t plus 1, because the car passes an additional second before the motorcycle moved or started his movement. Now we can reorder this equation to this one, t square minus 2vc times t divided by a minus 2vc divided by a. Now by substituting vc equal 50 meter per second, or the velocity of the car, and it's constant, and a is the acceleration of the motorcycle, which is equal 4 meter per second square. By substituting them in this equation, we can solve it by the general law for a quadratic equation in this way. And we can get two values of t, which is one is positive and the other is negative. And as we know, we must ignore the negative value.